We're now going to be looking at a branch of chemistry called organic chemistry. Now, organic chemistry is the study of any carbon-containing compound. So the basis of all organic molecules will be some sort of carbon chain. So the first thing that's worth knowing is that carbon will always form four bonds, four covalent bonds. And the reason for that is that carbon is group 4, therefore it has 4 outer electrons, so it's going to need to gain 4 more to get a full outer shell, and that's why it forms those 4 covalent bonds. So whenever you're drawing your organic molecule, double check that each of your carbon has formed 4 bonds. Leading on from that, the simplest type of organic molecules are hydrocarbons. So if I just put in hydrogens here, this is the simplest hydrocarbon. And the reason it's called a hydrocarbon is because it's a molecule containing carbon and hydrogen atoms only. There are other organic molecules that contain other elements, which we will look at, but essentially that is what a hydrocarbon is. So we are going to be looking at quite a few definitions today, and the first set of definitions we're going to look at are these ones here. So the first one is called an aliphatic compound. Now, organic molecules can be split up into an aliphatic compound, and later on we're going to look at an aromatic compound. So firstly, an aliphatic compound is a compound where the carbon atoms are joined in unbranched or branched chains or non-aromatic rings. So an example of that could essentially just be this over here. So we have carbons in a chain. This is technically unbranched, it's just a straight chain. And we could also have a branch one. So this one, if I replace that with a branch like that, that is also classed as an aliphatic compound. An alicyclic compound is a compound where carbon atoms can be joined in a non-aromatic ring. So essentially it's where we just have a ring of carbon atoms. So this is an example here, like that, and always double check each carbon is bonded to 4, or it has 4 bonds, sorry, like that. So I'm just showing you hydrocarbon examples just to make it slightly easier. But essentially this one over here is classed as an aliphatic compound. This one here is an alicyclic compound because it's carbon atoms joined in a non-aromatic ring. I will show you in a second what I mean by an aromatic ring. But the key thing to note here that both of these are classed as aliphatic compounds. So an alicyclic compound is also an aliphatic compound because it has a ring, a non-aromatic ring, so it does fit this definition over here for an aliphatic compound. So this one here is aliphatic, this one here is both aliphatic and alicyclic. So quickly just to mention what we mean by an aromatic ring. So an aromatic compound is one that contains a benzene ring. We won't look at benzene rings until second year, but I will just cover what an aromatic compound is. So an aromatic compound is a compound that contains a benzene ring. Okay, and a benzene ring is either drawn like this or it's drawn like this. As I said, we'll cover this in second year. For now, just be aware that if you see a molecule that contains this sort of structure, that's classed as an aromatic compound. If you have an aromatic compound, it's then not classed as an aliphatic or alicyclic compound. Okay, let's now move on to another definition where we're going to look at some examples. The first thing that's worth knowing is what a functional group is. So functional group, so the functional group of a molecule is the part of the molecule that's responsible for the chemical reactivity of that molecule. So there are different types of functional groups. We are going to look at a few in the next following videos. But essentially a skill that you need to have in organic chemistry is to be able to identify the different functional groups, because a molecule can have more than one functional group. Okay, so the first functional group that we are going to be looking at is an alkane. So you need to know what the names are and what they look like. An alkane is essentially a molecule that only has carbon single bonded to other carbons. Okay, so this over here is an alkane functional group. And this is what we're looking at firstly. So we are going to be looking at the alkane functional group and its reactivity. The next one we're going to look at is an alkene. Now, an alkene is where we have at least one carbon double bonded to another carbon in a molecule. Okay, so at least where it has one double bond, that is classed as an alkene functional group. And we can also have triple bonds in chemistry, and that's called the alkyne functional group, like so. And just bearing in mind, I haven't obviously drawn in the other atoms, but in all of these my carbon has formed 4 bonds. So a single bond between carbons is an alkane, double bond is an alkene, and triple bond is an alkyne. Let's now have a look at when we have other atoms, other elements in a compound as well. So if we ever see this functional group here, so where we have an OH bonded to our organic molecule, this is an alcohol functional group, or sometimes called the hydroxyl functional group. Okay, if we have an NH2 attached to the group, attached to the molecule, that is an amine functional group. If we see a carbon double bonded to an oxygen, we call this a carbonyl functional group, and that can be in either ketones or aldehydes. Don't worry too much about these if you don't know these names already. We will be looking at these in more detail. So that's a carbonyl. This one here, where we have a carbon double bonded to an oxygen and also bonded to an OH. This is what we call the carboxyl functional group, like so. Just to put some more in over here, so if we ever see a carbon bonded to a halogen, so that could be fluorine, chlorine, bromine, iodine. I'm just going to put in bromine here. So this is called a halo compound. Okay, so this is a halo compound. And if we ever see that benzene ring, so I'll just pop this in over here. So if we ever see this benzene ring like that, this is known as either a phenyl or a benzyl group, like so. Okay, so these are the different functional groups. As I said, we are going to cover a few over the next few lessons, or some in second year as well, where we'll get to know how to name these properly. Okay, so the next definition that is worth knowing is this one here. And this is the definition for a homologous series, which you may have done already at GCSE before. So it's usually worth 2 marks. So it's a family of compounds with similar chemical properties. So that's 1 mark. And the second mark is for whose successive members differ by an addition of a CH2 unit. And in the next video, we're going to be looking at the alkane homologous series, and we're going to see how this definition applies to that.